So difference of squares, as the video that you watch explained to you that when you're doing the difference of squares, all you need to do is just open two set of brackets. You take the square root of x squared, which is x, you put that here and here, and then you make one sign plus, one sign is minus, and then your square root of 16 is 4. You put 4 here and there. Now, when can we do that? Basically, you do that when you have a binomial, that means two terms. The middle sign has to be negative. If the middle sign is positive, you cannot do it. And why you cannot do it? Because you could ask yourself, if we take this and FOIL it, we get x squared minus 4x plus 4x plus, minus 16. When you collect like terms here, you get x squared, these two will cancel, and you get minus 16, which means you get this back. Okay, now how about if we think we could do this with x squared plus 16, because that's what I've seen some of you when you were working on number 4, that's what you did. You went, okay, that's x minus 60 minus 4, or x plus 4, that's what some of you did. Okay, if you did that, then you go back and FOIL this. If you FOIL this, you're going to get x squared plus 4x plus 4x plus 4x, or plus 16. Now that's x squared plus 8x plus 16, which is definitely not this. So you know what you've done here is wrong. So that when you're doing the difference of squares, that's called factoring using the difference of squares. You have to have a binomial, two terms, so 1, 2, and between them a negative sign. That's what you need, okay? So that's basically when you have that condition, then it's a difference of squares. You don't even have to think about what you're doing. All you need to do is just blindly put a minus, put a plus, take the square root of the first thing, you get 9x, and take the square root of 25, you get 5, you put this here and this, and 5 here and 5 there, sorry. Yeah, same thing here. That satisfies the condition for the factoring the difference of squares. So you open two set of brackets, and then plus minus square root of 4a squared is 2a, you put this here and there. And the square root of 9b squared is 3b here and here. Okay. Now the mistake that, or some of you didn't finish this. However, when I asked you to finish it, what you did, you made a mistake. So here, this factors into 9k squared, according to what we learned, plus 1, and then 9k squared minus 1. Okay, because square root of 81k to the 4 is 9k squared. You put this here and there, and then the square root of 1, you put this, which is 1, you put this here and there. Now, if you look at this, the condition we said about the difference of two squares is still in this brackets right here, because it's a minus in the middle. That's a perfect square. That's a perfect square. So your final answer should have been 9k squared. Okay, for this one, plus 1. So you don't touch this. We don't have the sum of squares, but we have the difference. This is sum, this is difference. So this, you keep it the same. This one here, you follow the same rule. You put one sign minus, one sign plus, take square root of 9k squared, you get 3k. You take the square root of 3k here, and then you take the square root of 1, that's 1 here, 1 there. Yeah. Here, even though it's a fraction, and some students are scared from fractions, they say don't be, that's still the difference of two squares, because that's a perfect square, that's a perfect square, that's a perfect square, that's a perfect square. And therefore, now the square root of x squared over 36, the square root of x squared is x. Okay. X, and then the square root of 36 is 6. You put that here and here, and then it's a minus and a plus. Square root of 49 over 121, the square root of 49 is 7 on top. The square root of 121 is 11 on the bottom, and you just repeat that right here. This here, does it follow the same thing? Yes, it does, of course, because it's a binomial. That's one term right here, and that's a second term. Binomial means two terms. You look at this because it's in the brackets and squared, you look at it as one term. Okay, so therefore you open two set of brackets. The square root of x minus 2 squared. When you square root something that's squared, you just cancel the square and you have x minus 2 and x minus 2. And then the square root, you put a plus or minus and minus, sorry. And then the square root of 9 is 3, so you put that here and there. Now this will give you x plus 1, because you simplify what's in here, and x minus 5, and that is the final answer for this. Then I gave you these three, guys. When I gave you these three here, and I said, remember the GCF. So I'm just gonna erase some of this. I think the first few you don't have a problem with. So, and if you have any questions, I'll go over them later, inshallah. So I'm just gonna. And so if we take the 8x squared minus 72, definitely it's a binomial. The middle sign is negative. But what's missing to factor this as the difference of two squares, you cannot do that right away. Why? Because 8 and 72, they're not perfect squares. So we have to have perfect squares to be able to factor the differences, to factor using the difference of two squares. So what can we do here? What I see here, I see a greatest common factor, which is 8. And then if you take out the greatest common factor, which is 8, then you're going to get x squared minus 9. And after that, you just carry the 8 when your answer. And this, the x squared minus 9, you could factor that by putting an x here, a minus, a plus. Square root of 9 is 3. So this here becomes the difference of two squares. Okay, so that's 7. 8. You have 7x to the 4 minus 7y to the 4. Does this meet the conditions for the difference of two squares? No, it doesn't, because of the 7. The 7 is not a perfect square, so we cannot do it. But I can see that I could take out 7 as the greatest common factor. And you're going to get x to the 4 minus y to the 4. And after that, I know I have the difference of two squares now, because the square root of x to the 4 is x squared. So I put this here and there. Then a plus, minus. Then the square root of y to the 4 is y squared here and here. But this becomes exactly like this, because this part right here still meet the conditions of the difference of two squares. So I carry my 7, I carry my x squared plus y squared. I cannot factor that because it's a plus in the middle. But this I could change it into x minus y, x plus y, using the method of factoring the difference of two squares. Because the square root of x squared is x minus plus square root of y squared, y. And then the last one, which is this. Here, I'm just gonna stick it in here and I'm gonna write a little bit smaller. I know I could take out 3m as the greatest common factor here. And I'm gonna get 9m squared minus 4. Now I carry the 3m, and this is definitely the difference of two squares. So I open two set of brackets. I'm gonna get 3m in this bracket and this bracket. And I'm gonna get a minus and a plus. And I'm going to get square root of 4, which is 2 here and there. And that is how you do these 4. Any questions? If you have any questions, please ask. When I am factoring, how do I know it's the difference of two squares? It has to be a binomial, two terms. The sign in the middle is negative, but also both terms have to be perfect squares. Now, if I look at these two terms, they're not perfect squares. Okay, so I cannot use the difference of squares yet to solve this. Now, the first thing we learned when we're doing factoring is how to take out the greatest common factor. So sometimes you have to do things in combination. You have to do the greatest common factor first, which is here. If you look at that, I could see I could take out the greatest common factor, which is 3m, and then this will be 9m squared minus 4. You remember I said when you take out the greatest common factor, just divide each term by it, and then you'll know what you get here and there. So 27 divided by 3 is 9, m cubed divided by m is m squared, minus, and then 12 divided by 3 is 4, m divided by m, it cancels. At this stage now, I keep the 3m and I open two set of brackets because I'm very happy to see the difference of two squares right here. 3m minus plus, and the square root of 4 is 2. Rahaf, does that make sense now? Okay, great. Everybody is happy? No questions? All right. This one here, it looks kind of complicated. You know, it's not your typical question doing the difference of two squares, but it still follows the same conditions. And the conditions, two terms, there's a minus, this because it's in brackets and squared, this is one term, and this is a second term. So we have two terms here, both of them are perfect squares. How do you know they're perfect squares? Because I have a square here and we have a square there. Okay, that makes them perfect squares. Now the sign in the middle is minus. So what you need to do, you need to go, the square root of x minus 2 squared is just x minus 2. So you put that in here and you put it in the other bracket as well, or the other set of brackets. And now you put a minus and a plus, and then you square root this. And when you square root, as I said, something squared, the square root will just cancel the square. So we're going to get x plus 3. And you notice I wrote the one on the right first. And here I have to open brackets when I write x plus 3. And the reason is, when you have a negative sign, it's going to change everything inside the brackets here. So when it's a plus, you don't need to put in brackets because nothing is going to change. But when it's a negative, you have to put what comes after the negative in brackets. All right. So again, factoring the difference of two squares. This is a perfect square. This is a perfect square. It's a minus in the middle. It's a binomial. And therefore, I take square root of this. I get x minus 2. I put that here and there. And then I put a minus here and a plus. So I put a minus and a plus. And then I square root this. It gives me x plus 3, x plus 3. And when it's a minus here, the x plus 3 here, I'm going to put it in brackets. Now, if we look at this, it's going to be x minus 2 minus x minus 3. But here, I could start collecting like terms. So x plus x is 2x. And negative 2 plus 3 is plus 1. And this, the x will cancel the x. And negative 2 minus 3 will give me negative 5. So I have negative 5 brackets 2x plus 1. And that's your right answer. So good job, Adam. You got it. You want me to give you another one like this? You want to try it? Let me know, please. Okay. So now, this question here, does it follow the condition of the difference of two squares, factoring the difference of two squares? You see, this is one term right here. This is the second term. So that makes this a binomial. Binomial means you have two terms. Are both of them perfect squares? Yes, 16 is perfect square, and the x minus 1, because of the square on top there, that makes that a perfect square. And this is one term. 9 is a perfect square, and x plus 1, because it has a square on top, it's a perfect square. So when that's the case, you know you could do it using factoring the difference of two squares. So what do? You open two set of brackets. You put minus in 1 and plus in 1. You take the square root of this. When you take the square root of this, the square root of 16 is 4. Don't forget to write the brackets, and the square root of x minus 1 squared is just x minus 1. So you write that here and here. Now you go to the second one here, you square root the 9 and you square root this. The square root of 9 is 3. And the square root of x plus 1 squared is just x plus 1. And you write that again in here. Now after this, it's just simplifying. From this step on, you just simplify. So how do we simplify? We simplify by distributing the 4 inside here. So we're going to get 4x minus 4. And then distributing the negative inside there. So it's going to be a negative 3x minus 3. And after that, we do the same thing here. Distribute the 4x minus 4. Distribute the 3 into here. It's going to be plus 3x plus 3. Now we go ahead and collect like terms. And here we're going to get x minus 7. And we're going to collect like terms right here. We're going to get 7x minus 1. So anybody who had that, they get the right answer. So anybody who had that, they get the right answer. Any questions? You know what? Let's do one more. Just make sure everybody gets it. And you have to post your answer. You have to post your answer. And then we'll start factoring trinomials next week. So again, the difference of 2 squares. This is a good example of the difference of 2 squares, factoring the difference of 2 squares. So what we need to do, open 2 set of brackets. So I'm just going to put square brackets right here, right here. The square root of all of this, the square root of 4 is 2. The square root of x minus 2, just squared, sorry, just x minus 2. So I put this here and in here as well, in both set of brackets. Now I make 1 plus, 1 minus. I square root this second term right here, x plus 9 squared, just going to be x plus 9. So I put x plus 9. Honestly, I don't need brackets because this is a plus. I don't need to write brackets. But when you write this here again, you have to have brackets. And the reason is because this is a minus sign. Now we're going to get 2x minus 4 plus x plus 9. Here we're going to get 2x minus 4 minus x minus 9. And therefore, the final answer will be 2x plus x is 3x. Negative 4 plus 9 is plus 5. And here is going to be 2x minus x is going to be x. Negative 4 minus 9 is negative 13. So anybody who wrote this answer, you got it correct. If you haven't, then go and review this. I will post this on YouTube so you could watch it again. Share it with friends if you like that are doing this course, or friends. It doesn't matter. Anywhere from grade 10 to grade 12. It's good for them to review this. So if you don't have any questions, it's 4:31 right now. We'll call it a day, inshallah. Okay.